Okay, and then question 4, which is the QER question, says magnesium chloride is a solid with a high melting point. It conducts electricity only when molten or dissolved. Describe the electronic changes that take place in the formation of magnesium chloride and explain its properties in terms of bonding and structure. You may use diagrams as part of your answer. So as far as the diagram is concerned, okay, this once again is an ionic compound. So we need to draw an ionic dot and cross diagram. So if we take magnesium, okay, magnesium is in group 2. Its configuration is 282. But for this type of diagram, we only need to draw the outer shell electrons. So we'll draw them on the left-hand side. Chlorine, that is the element that makes up the chloride, is in group 7. Okay, it has a configuration of 287. However, for this sort of diagram, we only need to draw the outer shell. So as it's got 7 electrons in its outer shell, it requires 1 more. So we'll need to draw 2 chlorines, because each chlorine is going to acquire 1 electron from the magnesium. Okay, so we'll just double check. 1, 2, 3, 4, 5, 6, 7 electrons. And the same for this chlorine here. So in the ionic bonding diagrams, we need to show the change. So because it's an ionic compound that consists of a metal and a non-metal, then we need to show that this electron here is given away, and this chlorine atom gains that electron to become a chloride ion. So when chlorine gains an electron, it becomes a chloride ion. And as this is an ionic bonding diagram, we need the arrow to show the change. So the magnesium, because it's lost those outer shell electrons, we don't need to draw the electron shell. We'll assume that the one beneath is now full, and because it's lost 2 electrons, it becomes 2+. The chlorides, each one, we will draw the outer shell electron simply because it's gained an electron. So it's important that we show we understand that. That's Cl, and because it's gained an electron, it becomes a minus, okay, or 1 minus. You don't need the 1, but maybe write it in there for completeness. And obviously, there's 2 of these, so I need to draw them both. And the formula of this overall is MgCl2. Okay, and we could put S for solid because ionic compounds are all solids due to the high strength of the bonds between the positive ions and the negative ions. Now, for the written aspect of this, I think it's probably best we just use the mark scheme. Okay, so in these sorts of questions, they're looking for what's known as indicative content, things that indicate you know what you're talking about, basically, and also further explanation. So the magnesium atom loses its 2 outer shell electrons. Well, we've illustrated that in the diagram, but it might be wise to mention that in your text. To become a positive ion, both chlorine atoms gain the electron to become negative ions, and the attraction between oppositely charged ions forms the overall compound. Further to that, they might want you to explain that the transfer of electrons is to gain full outer shell electrons. Okay, so in the case of the magnesium, it gains the full outer shell beneath the shell with 2 electrons, and in the case of chlorine, obviously it gains that 1 electron to fill the outer shell. The high melting point, and that's not, this part here is not obvious from your diagram, so you would have to add this. So high melting point due to the strong bonds between ions requiring that should say lots, shouldn't it? That's a typo, lots of energy to split them. It conducts electricity when molten or in solution, because only when then are charged ions. So it's the charge bit that's important. And as I've said on previous questions, a lot of people are very good at talking about delocalized electrons, but you do need to remember that ions, both positive and negative, as long as they're allowed to move, can also carry electricity. Okay, so anyway, only when they are charged ions are free to move and carry electrical charge to conduct. But when they're solids, the ions are immobile. Okay, so we've spoken about this in previous questions. In the solid lattice, whilst the ions are charged, they cannot move. So solid ionic compounds cannot conduct electricity, whereas liquid, i.e. molten or dissolved ionic compounds, can conduct electricity because their particles are both charged and mobile. Okay, and then the actual marks for these sorts of questions are banded. Okay, so if you write well and mention those points that have been mentioned previously, then you're looking at the 5 to 6 mark band. Okay, if you've got a basic description, okay, then you're looking at 3 to 4 marks. If you've not really had a good go at it, then obviously you're looking at the 1 to 2 mark band. So it's not as simple as ticking off these points. You do have to make sure that your quality of written communication is high as well. Okay.